should be inside or not?
No.
B should not be inside. Which is contradiction. Because assumption that B is in there. All right, let's see. Well, then B probably does not belong to itself. But if B does not belong to itself, what does it mean? It didn't pass the test. So it's not true that phi of B. So then what? If it's not true that phi of B, so it's not true that B does not belong to B, so B belongs to B. Contradiction again. That's all. So what happens? And that's a paradox. One of them should be true, but they are both false. And people got worried. Actually, there is a story. I never checked it really. I've heard it from someone. There was a big friend, German philosopher and mathematician, Gottlob Frege, and he was writing like encyclopedia of mathematics. And he was writing everything from the beginnings to establish whole body of mathematics, like carefully written from everything. And in the middle of Frege finishing the job, Russell Paradox posted this. And Frege just stopped writing. If it's all on kind of false foundations, then it doesn't make sense then to go to the fancy little details later on. It's all on false ground. And then mathematicians, as I said, came out of it, became more careful, made axioms for set theory, and one of the axioms is this comprehension axiom that says, yes, you can collectivize, we say, recognize the elements, but not from the whole universe. You must make a set and do things inside a set. So that's how they resolved it and said, just do those constructions more carefully. Now connected with this, and this is the famous Cantor's diagonal argument, and that argument you will see if you study some automata or formal languages, you will see that argument repeated a million times in formal proofs. Here is what is that halting problem. What is a halting problem? People were asking the following question. You see, so can we write the program halt of PD that does the following? If you enter in, what is P? P is the program. And D are some data. Program that calculates squares, or program that, let's say P is the program that, that factors number into primes. And then D are 20 numbers. I feed those numbers into program, and program at the end finishes their factorization, okay? People say the following, but what can happen? Can the program get stuck? And can the program loop? Sometimes, yes or no? My question, people wanted to know the following. Can I, because a problem when the program loops is the following. Like when you wait for a computer to finish something, it keeps rotating, and you are never sure if it's just taking long and it's going to finish in 2 minutes, or it's going to take forever, it's already in the loop and it will never finish. It's always a dilemma, because when the program finishes, you know, it's there. But when program is not finishing, you don't know which case it is. So people wanted to have a program halt to tell you, is it worth waiting? So that means, if someone that will answer yes, if halt, if P of D will eventually finish, and no, if P of D will loop. Be careful. This program doesn't execute, it doesn't finish the result, doesn't give you factorization, just tells you it will be done, just be patient. Okay, one says patient, be patient, or give up.
The halt will still say that.
What's it?
The halt will still say that, right? Isn't that the problem?
No. Here is the difference. This one will tell you, it will give you the answer. So when it loops, it just loops, and you are waiting. It might finish at the end or not. You have full ambiguity. And because if it loops, you will never get the answer. Because you don't know if it's taking too long or it will just never finish. But here you want someone to tell you yes or no. You do get the answer. It says, no, don't wait. This will take forever. Or, yes, it will finish when I don't know. What will be the result, I don't know, but wait, and the answer will come. Should you leave something for 10 days to run or not? So people wanted to have a program like this, yes.
I'm just curious, is this something like, if it will finish in like 1,000 years?
It doesn't matter. Oh, as long as it will it finish ever.
That's
Exactly.
very hard to determine.
What's it?
Very hard to determine.
But people wanted somehow to do in some analysis, thought that it might be possible to have that something that will tell you, find the glitch, like don't divide by zero, something like that, to somehow recognize syntactically or somehow through checking something, to tell you in advance to wait or for. And either such a program, and we have an easy proof that such a program cannot exist. Why?
Sure.
For the same reason as this, because you would feed it into itself. So here it is. If such a program P of D exists, then you will get a program Q that will do the following. If out of QQ says yes, then this one will say no. And then if this one says not out of QQ, if this one says yes, stop it, it will loop, not say no. It will loop, and then if not how, it will say stop, yes. And then the same way, if it doesn't belong to itself, then it will belong to itself, which is contradiction. If it does belong to itself, it will not. And that's why this halting program can work. So generally, there is no program that can predict if your program will stop or not. No, this is the proof that it cannot be done. So that, some people said, oh, it's not to be expected, but here is the proof that it cannot be done. Yes, sir.
Never mind.
Ah,
I can't wait.
okay,
It's okay, it's not that important.
okay. Just prepare your questions for the next time. So generally, section 3.4 is not really something that you need to learn on the technical level or expect questions about it, but just, and there are not even homework problems on it, but it just to be familiar with it, and then in some cases when it appears in your computer science, to kind of be aware that that is.
The other one, 3.3 is going to be
Yes.